Dark matter and dark energy. What is dark matter and dark energy? Astronomers have recently come to realize that there is an invisible or dark form of matter that is the dominant source of energy in the universe. They have also come to realize there is a dark form of energy that is driving the expansion of the universe.
Dark matter is an undetected form of mass that emits little to no light, but whose existence we can infer from its gravitational influence. Scientists have a much better understanding of what dark matter is not composed of than what dark matter is composed of. Dark energy is an unknown form of energy that seems to be the source of a repulsive force that is causing the expansion of the universe to accelerate.
Ingredients of the universe. According to NASA, scientists have fit a theoretical model of the universe with a combined set of cosmological observations and come up with a composition of the universe. It is approximately 68% dark energy, 27% dark matter, and 5% normal matter. It is interesting that matter we consider normal only makes up 5% of the universe.
Evidence for the existence of dark matter in spiral galaxies. If the majority of a galaxy's mass was in the center, like we once thought, we would expect the rotation curve to decline, but that is not what was found. Instead, the rotation curve of the galaxy stays flat. This means the mass must be more spread out, therefore we conclude that there is 10 times more invisible or dark mass than visible mass in the galaxies. In galaxy clusters, the scientists can measure the velocity of galaxies in a cluster by their Doppler shift. From this, scientists are able to derive the gravitational mass and compare it to the amount of mass we actually visibly see. They find that the gravitational mass is 50 times larger than the actual visible mass. Therefore, dark matter either really exists or our theory of gravity is all wrong. Since gravity has been so well tested for so long, we assume that the theory of gravity is correct and that there really is dark matter.
There are two basic ideas of what dark matter is. First, there are MACHOs, or massive compact halo objects, which are dark stars that are high in mass and present throughout much of the universe, but not in high enough numbers. Second, there are WIMPs, weakly interacting massive particle. WIMPs are not any form of detectable normal matter. They are leftover matter from the Big Bang, and they only react to gravity and weak forces. They cannot collapse on themselves, which would explain the flat rotational curve we see. WIMPs appear to be the most likely candidate. There is not enough normal matter to explain dark matter as MACHOs.
The Doppler effect is the change in frequency or wavelength of a wave for an observer moving relative to its source. The Doppler effect causes distant receding objects to have their light shifted toward the red end of the spectrum, or redshifted. It has been well known for a while that the universe is expanding. Since we know this, we would expect the light from distant supernova to be redshifted. And that is what we see. But surprisingly, they seem to be too redshifted to match the current calculated rate of expansion in the universe. This would mean that dark energy is causing the universe to expand quicker than we thought.
The identity of dark energy is still a mystery, but there are multiple theoretical explanations that are in the works. One explanation is that dark energy is a property of space. Einstein was first to understand that space is not nothing, but actually has properties we are yet to understand. Another explanation says empty space is full of virtual particles that form and then disappear continuously. But upon calculation, everything came out very wrong. Another explanation is that dark energy is a new energy fluid that affects the universe in the exact opposite way of matter and normal energy. And the last possibility is that our current theory of gravity is incorrect. There are candidate theories to take its place but not have been compelling to this point. And these are our sources. Thank you.